There it goes. Well, okay, so let's start with Zoxy, as you said, and then we'll, with the Zoxy PR, I mean. Let me share, I guess I'll share a window so that we have like a common thing. To look at. I don't know, Mark, did you want to? I'm sort of driving by default, but I'm happy to let you drive if you want.
I can probably try, but I also don't know exactly like what the main points we want to discuss are. I can give a brief overview of like the current situation and what the PR does. That'd be helpful.
Okay.
So there's a link in the, so the pull request is there. There's also links throughout the doc to like pieces of code and such. So we have, basically there's this structure that contains the current dependency graph, which we edit as we go through the compiler, like queries are run and such. The current situation is we just keep the whole structure behind one lock and acquire it whenever we want to change anything or read anything. Most of the fields are constant or just append only inside this structure, including total, like there's the anonymous seed, which I think we just use to like seed various queries. There's a forbidden edge, which is only used in debug mode, as well as total read count and total duplicate read count, which are also just debug mode for like printing.
So wait, hold up. Let's back up just a little bit.
Okay.
The structure we're talking about, maybe I can like load up the code, is this graph, right? The dep graph that stores the dependencies for incremental compilation.
Yeah, so we are talking about current dep graph in that file.
Yeah, so this is the dep graph.
That's like the, you want.
This is like the definition of it, right? Yeah.
Yes.
So we're talking about this structure, current dep graph. Okay. Right.
And so it has these fields, and the main two of sort of concern are data and node-to-node index. This is essentially the two fields form sort of a index map from dep node to dep node data, where we have just the two because like we have this dep node index idea.
Right. Right. So
and yeah.
So when you add a new thing to the graph, it has some dep node. We assign that an index, and then we push something on this vector. So these obviously need to be kept in sync.
Right. Yeah, but most of the time we're not actively adding things, so we're just looking things up by, like we look up a dep node index, and then we look up a dep node data based on that. But it's not like anything too difficult. And then
this is what we're looking at now. Is this is the version that Zoxy
right
from Zoxy's PR. So these are separately locked in this version. Okay, and then you're saying then there are these other fields that are like debug data. Okay.
The forbidden edge and total read count and total duplicate read count are only touched with debug asserts on for like printing, and the forbidden edges, I think so. Like you can set an environment variable to say, oh, this is not allowed to be touched.
Yeah, the forbidden edge is used if you're debugging why did this dependency exist that's causing me to recompile too many things. Then forbidden edge will abort when the edge is added, so you can like see the stack trace and understand what the heck was going on. I think it's basically set in startup.
Yeah, it's only set once, and after that it's only read. So it's sort of there's no need for a lock around it.
Okay, so we basically want to look then. I mean, the main danger here would be we have two locks, so you could be in an inconsistent state, or you could access them in some, like you could hold this, we could access them in an inconsistent order. I think in some prior review, I asked for this comment to be added, so we have a documented order that says what order you should hold them in. So that's
and there's not too many places they're like touched, and both are only acquired when we're pushing new nodes. So at least as far as I could tell,
the only time they're both acquired simultaneously.
Yeah.
Yeah, that makes sense. I think you don't have like the node to node index. Maybe we'll just search for that.
Mm-hmm.
Isn't modified that much at all, right? So here we do a debug assertion. That's okay. Is it okay? Where is this function called from? Alec node. We'll come back to that. Well, I guess it must be okay because intern node is about to acquire the lock. I was just wondering if Alec node would be called with the lock already held. So intern node, this is presumably where they're this is where they both are acquired. Yeah.
This is the only place I found where both of them are acquired, and here it sort of looks trivially correct.
Yeah. So the only other place when you read a node, we first get the index and then we read from it. Okay. And they're not held in an overlapping way. Mm-hmm. I guess we could use read-write locks here, right? There's like this is a classic read-write lock pattern. But,
right, yeah. My impression is that like we probably don't need to, but it could be a performance optimization.
Yeah, no, there would not be any reason to have to.
Based on some conversation with Soxy and like looking around at other pull requests, I get the impression that like this pull request is not an end state. It's like a small.
Right, I remember it was part of a much bigger thing.
So in some sense, this pull request by itself has no purpose. Like it doesn't actually benefit any code from a performance or anything.
Okay.
If there's a concern about the dual lock, should this just be an index map instead?
We tried that. It's slower.
Is that just because it's not a hash brown style map, or?
Yeah, that's my impression.
Okay.
I'm not really concerned about the dual lock. I think the main thing is we can summarize the set of, they're like private data. We can summarize the set of operations that are done, and it's pretty straightforward. And I'm just skimming through, like, so here we assume the thing's already. This just looks it up and assumes it's already there. I don't know what this option is, but yeah, it seems fine.
It's if incremental is off.
Okay, yeah. I guess it seems fine. That's all the node-to-node indexes, right? Oh, no, Yep, now we looped around. So I think it's good. We can probably land it. Is there, I guess the question would be like, is there anything else we want to?
There is one other concern with total read count and total duplicate read count. We're moving them to atomics. Right. And there is sort of this weird situation where we are fetch add with essentially consistent ordering, which is fine. But then when we read them, we're for some reason using acquire ordering, which is correct, but seems odd.
Really, we probably don't need any ordering at all, to be honest, because we're not using them to synchronize.
Right, yeah.
So it doesn't really matter, but yeah.
It feels like, at least to me, it seems like it's good to either stick with sequentially consistent or like at least document why we're doing two different things.
Yeah.
Read and write.
I think these are used for like profiling or something, right?
We only use them when like printing when the compilation is over and such.
I don't know what edge deduplication data is, but yeah, it's some kind of thing we're going to dump out at the end. Sequentially consistent would probably be better anyway, because I don't know, in theory, acquire might give you an old value. I think I forget exactly what the rules are about that, but I don't think you're guaranteed to get the most up-to-date value with acquire. But that won't be a real problem. Anyway.
Seems like it's likely this would be read after some other synchronization anyway.
Surely, yes. It's a moot point. I agree. We might as well use it sequentially consistent.
Well, mainly my point is like if we're going to optimize, we should probably be fetch adding in like a relaxed fashion, because I think that's like the correct thing to do for counters that you don't care to use for locking and such. But it seems like sequentially consistent is good enough.
That sounds correct.
The other concern that I had is that the code previously had one lock, but now it has two, and current depth graph is, like, the fields are private, but this is a pretty large module, and there might be some sort of idea where we say, like, oh, we should try to not have.
Yeah, I mean, what I'm not crazy about in general, or like, I think what you're saying is just that it's not really, like current depth graph, for example, is not a really coherent abstraction. You can kind of see right here.
Right. Yeah.
Like
we should not be in non-current depth graph code reaching into its locks and touching them.
I think the real boundary is the depth graph, I think, is the answer. Right. Whether that's okay, I guess, is a question. But this is the real structure.
Mm-hmm.
And there are some other locks around here. But I mean, what's not entirely obvious, I'm looking around, like when you expect to be called with the data sort of already locked, like the fact that we reach in from the outside and get the lock makes it not entirely clear. If you call a method and it locks, that would be bad. Like this intern node method. In other words, you see what I mean?
Mm-hmm. Yeah, and that's part of why, like, I have this desire to stick it in a module that's private, or at least like not use the fields. It's like practically impossible to audit whether we ever do that.
I guess the question would be whether, like, how hard would it be to extract proper methods for these things? Where there's a case where we get self.current.data.lock. So this, for example, this code would want to be pulled into a method probably, right?
Mm-hmm.
But it also reads, well, the forbidden edge is a field of current. So this code you could totally do, it looks like.
Yeah, I think most of the cases is like they're fairly straightforward to pull out into like methods.
Yeah, sort of looks like that. This one
I also get the impression that, like, again, this is a very preliminary pull request, and like the other ones probably reshuffle half this code anyway. So doing that work up front could be like not worth it. It's all going to get moved around anyway.
Yeah, if I recall, it's part of some effort to like load the depth graph in some out of order way or something, in a more flexible way. Okay, I think we should land this PR, but I think this is a good example of maybe we could, or one thing we could do is like file an issue for later, or in other words, we can note this concern and say like, this is something we would like to revisit, but try to make those operations more atomic. But in light of the fact that it's part of a series, maybe not just yet.
Do we want to leave a comment about the acquirer orderings?
Yeah, let's fix that. Just to be simpler. It's not a big deal, but Okay. I'm just taking a few notes. 63756. So yeah, the TLDR is okay, but we prefer, or it'd be nice to extract the current depth graph to its own module with privacy boundaries so that it's more audible. I think that's a good general rule. Like if you have interior immutability, and it's a lot of code, kind of, it should try to make it a coherent unit, right? As small a unit as possible so it can be audited. So should we look at the lint store? Are we done at
The
this
lint
one?
store is much more sort of complicated.
Yes.
Although
Yes,
in some sense, it's sort of also a case study of we just don't have incremental in this area yet, because incremental would largely remove your lock entirely.
Yes, as I recall, it's kind of a big mess, this whole lint thing. I mean, the other option would, but that's what we prepared, so we might as well look at it. So you want to walk through it, Mark, since you prepared this?
Sure. Yeah. So we have the lint store is where we store what we call like past objects, which gets into sort of a quirk of our registration system, where instead of registering lints, you register essentially passes, which are like visitors, and we will, when we get around to running lints, take the sort of list of passes out, stealing it, and then mutably have now a unique pointer to the each pass object, run the pass, which basically involves traversing like a tree of cure nodes or whatever, and then that emits into like session diagnostics and such. And that's like the primary reason we have the block. The other reason is that when we're sort of building up session, we don't always have unique access to it in like a plugin or other sort of places in the compiler where we want to register things into the lint store.
So currently, if I recall, we do a lot of swapping, right? So we have like, I think that's what you were saying here. So we don't actually use the lock for much. We sort of make our own lock by swapping it out with none. We take all the data, put none in there, and then we can really traverse it. And
yeah. Yeah, the current code had this weird behavior of also like putting it back in, which, as far as I could tell, like was never actually used, but is interesting.
There's all this other stuff like, well, the compiler lints that are built into the compiler, sometimes they're registered as lints, and sometimes they just run on their own. Like they're just hard-coded throughout the compiler.
And one of the sort of weird things about this is that in some sense we always know the list of passes at compile time, module like plugins, but even though we sort of know it, we still have this need for locks because we register like a visitor instead of like a builder for the visitor. And that is sort of a larger cleanup, but is one that would simplify this code, sort of.
Yeah, so you're saying instead of registering something that has mutable state, you'd be better off registering something that creates the mutable state and then invoking it like a closure. Yeah.
Basically, yeah. And we already have this for like incremental passes. We have a thing that's like creates fresh passes out of old passes. But it doesn't actually, like that, the code sort of half exists. It just panics currently. There's no like actual definition. But
So the lint store is in a read-write lock.
Mhm.
So we're saying we do like a mutable borrow on the lint store, right?
Right, for registration only, which is like probably always going to be single threaded. So in some sense.
Yeah. The registration could, oh, okay, that's fine. And then in the actual lint code, there's a bunch, because of that, like because we only do a mutable access during registration, the actual lint store has a lot of interior mutability too, right?
Right, yeah.
Where is
Well,
it defined? Oh, here it is.
Libra C lint context, yeah.
I remember I always have a hard time finding it. And this is where we do the swapping with none.
Right, yeah. And then this is on sort of a branch I'm working on to sort of clean it up a little bit. On master, there's just like these locks don't exist, and we just borrow mute like the whole lint store, which is sort of complicated to audit and such.
Okay. Even, I see.
Mostly because there's code that sort of does like diagnostic things that like queries future incompatible for that information, and that's hard to pull apart.
So if we were to refactor this, the hardest part probably would be coordinating Clippy. Like, it doesn't sound that hard to register a builder, does it?
The complication in some sense is that currently, for performance reasons, we don't actually like the compiler itself registers one element into each of these vectors by combining all of the visitors into one single like visitor and calling itself recursively. When you register a builder, you sort of, I mean, you could do something similar, I guess.
Yeah, we'd have just like one big old builder or something.
That produces what it currently registers directly. Yeah, I think it wouldn't be too hard. You don't gain too much because you still like want the lock around the lint store because of registration.
Well, what you gain is that that's the only lock, basically.
Sure.
It's relatively, then the lint store itself is kind of, is straightforward code.
Yeah. I think that it would be fairly simple to make that change. Yeah.
I feel like that's like the kind of thing. I feel like that's worth doing. Like, I guess I feel like that's a medium priority in the sense of we think this code is correct. There's no bug. I kind of think most of the code is correct. So our goal here is really like to make it so that it's more obvious that it's correct. This was already kind of confusing, period, without Rustc, without locks. But.
There is, I think, one area that sort of I came across that was interesting here, which is, let me see. Yeah, so if you search for late module passes in this, yeah, and then you want like the fifth or so. No, that's not it. Yeah, here. So there is this interesting interaction with queries where we acquire the lint store itself sort of recursively within a query, which is like somewhat fine because it's just a read-only lock, but it's hard to audit in some sense.
Where's the, like, you mean
this
like
function? This function is, yeah, this is a query function. Well, it's, yeah.
Presumably the idea is once you get into the queries, the lint store is frozen.
Mm-hmm.
Right?
That's a theory, yeah. It's kind of like, don't like actually know that. statically, obviously, but
We could document it.
yeah.
At least then we would say it's a bug if it's not true. I don't know. Yeah, we don't know that it's actually true, but as far as you know, that's true, right? From in practice.
It is like, it would be wrong for it to be untrue, and
right.
not only wrong, but also like you would not expect the code to behave in an expected manner.
Code would do weird stuff because there would be nuns in
Yeah.
these vectors where they're not supposed to be. So in that case, if we document that, then this seems harmless, kind of. And it would be kind of nice if we could enforce it some way, but I think it's okay to document it for now. Why is this all public, by the way? Maybe we could enforce it by like a little bit better by making this field not public, so that when you just sort of,
it's used in a lot of places. If you look at there's a list also.
They must also be borrowing it, right?
Yeah, they're all borrows. So we could like provide a read-only accessor on session, it's public or something like that.
But you get what I had in mind. Then you get into the pattern we're not crazy about of the lock lifetime being unauditable, but then we did say like that's
right. Yeah, I was even thinking like potentially what the abstraction we want here is some sort of like frozen lock that you can like lock up to a point, and then you say now you're read only, and then at that point it just like deref.
I think what we really want is the lint store. The session structure sucks, period. Like overall, anyway. We really want is that this thing is not in a lock in the query system. It's just accessible. It's just owned and frozen. Like, I guess the other refactoring would be to, how would that even work? Like ideally you would make the lint store and set it up and then create the session and give it a setup lint store. Would that be super hard to do? Probably.
That is due to plugins and like impossible. Modular plugins. The main concern is that like we could probably throw it inside like TY context, like steal it from the session and then say everyone should be using it from there as like just a read-only access via like a method or whatever. That would be not super hard, I imagine.
That's not the worst idea. I wonder how many things fit this pattern. Because you could imagine the session having like a setup field or something that encapsulates stuff that is mutable during setup, but then gets stolen. And you're not supposed to use it. I don't know, it might turn out to be kind of annoying. But.
It's sort of, but also it's like it'll go away once we move queries back farther and farther, because we have sort of a lot of this stuff is essentially a query around like give me lints could be a query, and then like you wouldn't even need.
So when you said frozen, were you imagining like a read-write lock that you could sort of hidden inside of another thing, and you can call a freeze method, and sort of at that point it no longer permits write locks.
Right.
And then maybe it has some unsafe code to let you get an interior reference out or something.
Right. Yeah. And I was even thinking going sort of one step farther and maybe even like straight up implementing like deref on that structure and just having it panic unless it's frozen or something like that.
Yeah, plausible.
So it's like sort of, it looks as if it's normal.
Yeah, you can have a foot gun but it would be very easy to screw it up during the setup phase, but it implements deref.
But it's also like the setup phase, so most likely you're going to hit it.
Good point. I think that seems okay. I think I sort of mildly prefer if we can move it to type context and have it like just actually be in an arc or whatever, and you never have to think about it because you know it's frozen. But so it seems like we got two things then. First, we can clean up so it doesn't have interior mutability, and then we can look at how to take this session pattern and either add a frozen to make it explicit or move to TCX. query. I mean, what you could even do is have there be an actual query that steals from the session.
Mm-hmm.
It's not like, I don't know if that's actually how we want to do it, but when you first use the query, at that point it gets stolen and it's cached after that. So can never.
Yeah. One sort of question I had with the query system, is there any way to sort of define a parameter to a query that's not part of like the query system? So a lot of the time, like for example, here it would be convenient to pass in like a reference to the link store to some of the queries.
Well, that's why, no, I don't think there's a way to do that at present. But I think that's why you'd want to have it's probably why I brought up the term arc, because I would imagine you might want to I think there should be like a tcx.lint_store query that gives you back the lint store. But in anyway, in Salsa, I'm working on some change that lets you get back references, so you don't have to put everything in arcs. We don't use Salsa, so it doesn't matter. Yeah, there's not a way to do that.
Okay. It didn't look like it was the case, but I think that was pretty much it for this.
Okay. Should we look at something else? You did some measurements also.
Yeah, we can look at the measurements. I can put a link in.
Might as well. I guess I'm going to make this into a minutes. Why not? At least for now. Let's put some notes here. So, conclusions. Code seems correct, but could be made simpler. Remove lock of option or whatever inside of lint store, and register a builder instead of the pass itself. I wonder, it would be worth pinging Manish or Ali to ask them about that. If there's like some reason, I feel confident that some lints do something horrible, though I don't know what it is. Not sure exactly what that would be, though.
Yeah, we only run lints like
once, I guess.
Yeah, so there's nothing really.
Still worth pinging them, but yes, it doesn't sound like it should be too bad. Can we sort of remove the read-write lock somehow from session? One idea is frozen pattern that maybe implements deref. Another is to steal from the session when creating TCX and expose via a query. The only other, yeah, I guess that's fine. That's good. Josh, Santiago, everything okay? Mark and I have been kind of ping-ponging here. Not sure if you all are able to follow or not. But.
I'm following, yeah.
I'm just looking.
Okay, well, we can take a look at the measurements. There's a thing. Yeah, so we discussed this a little bit with Alex as well in Zula. The loose conclusion is like the data looks good, but is sort of also horrible in terms of like the average CPU usage is nowhere near 100%, no matter what we do.
Yeah,
But
and the
master
scaling is
even worse than parallel, but parallel also doesn't get even into like the 90s. So
this one's really great. What is this showing? Okay, master is a non-parallel enabled compiler.
Mhm.
Did you also gather the like T1 data?
Yeah, well, we didn't gather it for like full crate graph timings because that didn't seem super interesting. But let me move the links to the perf testing.
So, okay, I sort of missed out. These are full crate graph timings.
Yes, and if you look, the links all lead to like the cargo fancy graph stuff that was recently added. My recommendation is to set min unit time up to like 30. Which is like nice. Then you get the CPU usage graph.
Okay.
Mainly what we see here across most of the graphs is like in parallel mode, you have less flat areas of like one core being used, which is what we'd expect. But
Where's the word money? I guess it didn't open in another tab. Okay. I was going to compare to master. So this is like, that was with one thread, right? And this is
with 16 threads.
you need like a, okay, I see.
Yeah.
Okay. All right. Yeah, so we knew scalability wasn't great.
Yeah. And then we also have some links at the bottom of the planning doc.
Down here.
Yeah, so there's two links to Perf Suite with sort of virtual cores and just physical cores, which corresponds to J4 and J8 on the Perf server. And then there's also a link to J1, or not J1, but like threads equals 1, which is like worst case.
And does threads equal 1 affect LLVM? Or not?
No, it strictly affects like the query parallelization.
Okay. Yeah. Last time I remember I dumped this into a spreadsheet because we wanted to filter out like tiny things like this. From 0.17 to 0.21. Yeah, okay. But I guess just looking at the max regressions.
You probably want to change to, or I think this might be a timing link already. I'm not sure. But
What is a timing link?
wall time. It's probably wall time. It looks like wall time. Yeah, that's what that. The numbers are small. It's full time.
Because it doesn't look too bad.
Yeah, it's not. I mean, it's not great, but it's also not bad. In some sense, we would sort of. I think Alex felt that the complexity of modifying the compiler and like potential for bugs and such is not worth the small wins we get in sort of whole crate graph timings.
Yeah, but well, I guess the question is whether we expect it to eventually be worth it. I mean, shipping with this, with the default being that it's disabled, is pretty low risk and lets us iterate more, right? But there's also some complexity we carry now just by having two modes and not building with this enabled and everything. But
I do think it's like, personally, I would consider it fairly viable to ship like the sort of larger crates like servo, they regress by maybe like a second at most, maybe I guess 2 seconds, which seems fine.
Is there an easy way to see what is the maximum wall clock regression, not percentage?
Probably not.
Yeah, I guess just look at style servo opt. That's probably the answer. It's the worst case of everything. Or not style servo, the other one, script servo.
So it's 5 seconds worse.
They won't be thrilled, but they won't notice. Yeah, okay. Still, it's a shame to regress, but all right. But I think that shows that it's not like, probably the best place to put our energy is into improving the performance of when we have cores, and not so much the single core. They may turn out to be similar tasks, but
it is worth noting that sort of for the possibly somewhat common and somewhat desirable situation of I have cores and I am building something from scratch. Like if you're on Nightly and you update your Nightly and you're building your whole crate graph from scratch, this is a big win, like up to a minute in some cases.
Yeah, I mean, I feel like people would be happy to see these results. I mean, like we would definitely have to sell them with a grain of salt, though. Like it's very much a work in progress. Interactions of job server and so on are complicated, but you can see big improvements. Well, should we talk, like, what am I going to ask? It seems like we all thought that job server interactions were a likely source of problems here. Do we know that or have data on that?
We do not have super good data on sort of, and I was not able to find time to even like figure out where we acquired the logs and such. So
maybe the question is, what should we talk about next time? And how do we prioritize like these sorts of refactorings with going through the code in more detail? Well, I'm going to try to note some conclusions. So measurements, there's also some wall clock data down here at the bottom. It seemed like our conclusions were single or -J1 performance is not too bad for very large crates. So approximately 5 to 10% for very large crates, e.g. script servo, that amounts to a few seconds from a like minute or multiple minute build, right? It also fits with, I recall there being some data we saw of like, when do humans start to notice things? And it was around 20%. Scalability is not great, but for a full crate graph build can, like if we did ship it, or can be significant wins. If we did ship it, we might ship with just like maximum J2 by default or something, right?
We could.
I don't know.
Yeah, I don't know. We haven't like made timing of whether that's worth it.
Right.
Could be.
That could also be worth it for the memory overhead problems and other things that Alex noted.
Sure.
Yeah, we didn't talk about memory here, I guess.
I don't think Cargo currently collects that, so we don't have data on it. Yeah.
So what to discuss next time? I could see discussing the Rayon fork changes. I could see discussing job server. I could see further audits. I don't know.
So my immediate concern for Rayon is just landing that rebase, and I've pinged Zoxia on it and not gotten any reply. So I don't know if you or someone else can take the reins on that.
I think we can certainly land the rebase. The only thing that could be hard, which I should be able to get, I can ping Zoxia about. I think at the moment, if I recall, Zoxia is the only owner of this crate. Oh no, it's not true anymore. Okay, very good.
Check the core too, but yeah.
Core, oh yeah, that may be a problem. Forgot there's 2 cores. Okay, well in that case, that should be no problem. You just rebased, as I recall, right? So,
Yeah, so you probably need to do a semver bump on it, and
yeah, we'll just, who cares? We'll just do an semver bump, whether or not it makes sense.
Right.
There shouldn't be anyone relying on it, and if they are, well, tough.
Right.
I still want to talk about it just because I don't, but I think I'd rather talk about the job server stuff because that feels like more important and also relevant too.
Right. And it's related to Rayon too, because it's one of the patches was to put hooks every time Rayon sleeps, basically, and it's releasing and acquiring job server handles when it does that.
Right. One of the things I was just thinking, one of the things we could do as an outcome from this like meeting is start to develop some parallel guidelines. Like, it feels like we came up already with some heuristics, but we didn't write them down. Like, if you have interior mutability, you should do XXX. Document your lock ordering. Try to have a module boundary that's strong. And also the patterns we are seeing, like the initialization pattern.
You talking about, is it a general guide or a Rustc specific guide?
Rustc specific. I'm thinking about a Rustc guide chapter with here are the guidelines, and we have audited all the code, but new code should be audited against these guidelines, right? And we have to sort of develop them as we go, but our guidelines, is that the right term? I don't know. Guidelines and conventions or something. That seems like we could start it now.
Yeah.
So another thing would be like atomic orderings, use sequentially consistent everywhere unless there is a, actually I wonder if we could do strong reason to do otherwise. If so, it should be documented. I wonder if we could make a constant actually. I've noticed one thing I find annoying about orderings is that if you just use sequentially consistent everywhere, there's no document, like it's not obvious if you require that for some reason, or you just didn't want to think about it. I wonder if we could make a constant that's like some ordering. I didn't want to think about it. I use this constant. I document it.
Ordering whatever.
Right.
One option there is we already have like an atomic type or atomic cell or something in like the sync module. We could like re-export atomics with all of their methods overridden to not take an ordering.
Yeah. So it'd be like, if for some reason it's important, you should use the
normal
ones, but otherwise this is like the default. I would be okay with that. I think it'll still be mildly ambiguous, but as long as we document, I think it would be fine. Like I could even see you're saying, if it's crucial that you use sequentially consistent, you should use the explicit version.
Right.
That's pretty unusual. It happens in Rayon here and there. But I would be surprised if it ever happened in Rustc. It would seem like a bug on our part, unless we're building some super low-level thing.
Probably shouldn't be in Rustc.
Right, exactly. It should be in some other crate. Okay, so we came up with atomic orderings. We came up with interior mutability in a struct, always private fields, document lock ordering if there are multiple locks, and try to keep overall size under control. I don't know. Try to minimize overall size of module. Something like that.
And maybe also a note of like, don't expose the locks.
Yeah. Is that different from always private fields?
Well, I mean, I was thinking like, or don't expose like guards in methods.
Okay. Yes. Don't return guards or have open-ended locking patterns, essentially. This was sort of a question, not so much a conclusion. But I wonder how often it's going to come up. I feel like it's going to come up. Session seems like one of those types that's pretty messy for this reason. So, okay. So what is the, did we decide what we're going to talk about next time, and or do we want to like assign tasks for the intern? Or do we just want to leave it at this?
I think it would probably be good to sort of assign tasks, at least loosely. My plan is to take on the link store cleanup and such.
That sounds good. I like the idea of, I think we should try to do these cleanups. Like, we shouldn't just go through all the code and then start working. Partly because probably we will, both because we'll actually get work done and because we'll learn if maybe some of our ideas don't work out so well sooner rather than later.
Mm-hmm. Yeah. The other thing, I think maybe Josh would be good to look into the job server if you'll be available next Monday.
Look into it in what way?
Sort of at least prepare on sort of what we do today and maybe some ideas of like.
Okay.
Basically, if you could have like a few minutes to talk about what we do, that would be awesome. It might be worth pinging Alex for that.
And it would also be good to sort of, along with that, I think, prepare sort of a note or two on sort of what Rayon does in terms of like how often do we expect Rayon to sleep? And we talked briefly also about the sort of slow start Rayon idea on Zulip, which would be good to, if you have time, see if like that's viable or if like Rayon is not an option if we want to do that.
You mean like the thread creation slow start?
Right. Yeah.
Yeah.
Should should definitely ping Alex, because I think the other thing to discuss would be like how the LLVM. That's the other thing we have that's sort of integrating with Chop Server to a certain extent. So we want to talk about how that whole handoff works. Okay. This all sounds great. Do we want to, the only other thing was this guidelines thing, which I think shouldn't take very long. Just wants like a preliminary Rustc guide PR or something. Okay. I'm happy. Actually, yeah, okay. I can land and publish the Rayon thing. Try to do that.
I'll probably tag you for the Rust CPR once that's ready too.
Yes. Sounds good.
Is there something where I can help? Like, I don't know.
I was going to say, Santiago, if you want to do this, but could try that.
Which one?
Creating an initial Rustc guide PR to document these guidelines we talked about that will evolve over time.
I think you would, I don't know if you have time. I might also try to take a look and sort of find another interesting lock or public lock or something, and try to type up some docs on what we do today. And
Yeah, I'm thinking now a Rustc guide feels a little overkill. Yet, maybe we'll just make a HackMD document. Like, it'll take 2 seconds. I will literally copy that text that we have right there, and that'll be our guidelines document, and we can evolve it. And after we've done like at least 2 or 3, we'll have some better idea.
Well, now you took away Santiago's task.
I know. We'll give him something. We'll find something else. Well, what were you just saying before I interrupted you, Mark? Find another.
Yeah, find another lock or something. One possible idea is to look at the primitives we're using in sync and sort of come up with some documentation on what the purpose of each one is, why we need it, maybe.
You mean in the librustc data structures?
Yeah.
Sync. Were you suggesting that Santiago could do that?
Yeah. Okay.
Yeah, that was.
I agree. Okay, great. I'll do this because it'll take me 2 seconds. All right, this was awesome. See you all next time.
Okay. See you all.
And or during the week. Okay.
Yeah.
Bye.
Okay. Bye bye.